The toilet gets its water from gray water used after hand washing. The water flows from the water basin into the reservoir, as seen here. This used less than 150 cc's of water.
After the person has deposited the water into the seal and has used the restroom, they simply turn this lever, releasing the water and the waste, and then the counterweight pulls it back up once they let go, sealing in all the pathogens that are in the reservoir.
After the waste leaves the seal, it travels down the slope in the back of the chamber. The point of that slope is to concentrate all of the waste behind the plexiglass, as seen here. The point of the plexiglass is to allow sunlight into the chamber. Sunlight contains UV rays which can neutralize the bacteria, helping to prevent infection of the person using the chamber. Now, letting in sunlight will also heat up the chamber with the intention of dehydrating the waste. Dehydrating the waste prevents the bacteria from getting that moisture, which can also kill them. These two methods will hopefully kill most of the bacteria in the chamber. In order to remove hazardous air and bacteria from the chamber, we wanted a ventilation system. Now, since we aren't using electricity, that ventilation system has to be mechanically driven. That's where we got the idea for a falling weight. Now, the user simply places this mass on the ramp and allows it to fall. That turns the spool to which the rope is connected. A shaft is then driven, and hence the fan turns. When that fan turns, it draws air out of the reservoir, up out of this tubing, and out of the chamber where the person is using the restroom. Now, this is important because when the user turns the seal, allowing their waste to fall into the reservoir, it can release hazardous bacteria into the chamber with the person, possibly infecting them. Now, some of the design features of this, we wanted a ramp here instead of just allowing the mass to free fall, because the mass will increase the amount of time that the weight is falling. If you look here, if you just release the mass by gravity, it falls incredibly quickly. The ramp adds some friction forces, allowing it to fall more slowly.
One go. After looking at component by component of our actual design, we've proven that the constraints as well as the customer needs were met during this project. For instance, we met the 150 cc's of water in the seal, as you could see in the very beginning of the video, as well as primitive supplies were used with wood, simple cement, as well as other plastic bottles and things that we found around. Finally, we made it so there's no electricity or plumbing. This went with our idea for $150 or less for the actual production because of the low economy. Thank you for watching this video, and if you have any questions, feel free to ask.